A square plate of 60 side is resting on HP on one of its corners. So the object is a square plate. The dimension is 60 Let's say it has got corners A, B, C, D. Out of those corners, let's say it is resting on this corner A on HP in such a way that its surface makes an angle of 45 degree with HP. So surface is also inclined to HP. Draw the projections of the square plate when diagonal passing through that corner on HP makes 30 degree with VP. Okay. So the object is resting in HP, surface is inclined to HP. So for drawing basic view, we need to make it parallel to HP. So true shape is going to be visible in HP, that is nothing but in top view. So first step of solution is going to be top view. So in a top view, we are supposed to draw a square, and the resting reference is corner. It is resting on its corner on HP. So when you are drawing a square, we need to keep corner at the left. Okay, so let's say this is the square. This is point A, B, C and D. Once you have drawn that view, project all the points for the front view. Project all the points for the okay. So this is going to be our front view. It was resting on one of the point on HP, and we have made it completely rest on the HP. So whole front view is going to be located on the XY line. So this is A dash, B dash, C dash and D dash. Now this is the basic view. Now we are going to consider the surface inclination. So let's locate this A dash first, because that point is supposed to be kept on HP. The surface is 40 degree inclined to HP. So this is a 40 degree line. On this line we need to redraw this front view. So same dimensions from the first front view. Take same dimensions in a compass and locate this front view once again. Also locate the intermediate points. So this will be the second front view. Now project this front view or all the reference point from the front view for the top view. From first front view, project all the points and connect the respective points. So this is A1, this is B1, this is C1 and this is D1. Connect those points and complete the view. So here you are going to get the rhombus. Now the diagonal through the corner in HP makes 30 degree inclination with VP. So diagonal through the corner in HP. So this is the diagonal AC. This is true length because we have made that diagonal or the plane parallel to HP. This is A1C1. Here, because of providing inclination to the plane with HP, this length is going to be reduced. So this is going to be a top view. Okay. Now if you are going to draw top view, the required angle is not alpha, required angle is beta, and if you are going to draw true length inclined to VP, the required angle is phi. So if you read the statement carefully, it says that diagonal passing through that corner makes an angle 30 degree with VP. So this angle is phi. So draw a line incline at 30 degree on this diagonal. Let's say I have located this point A1 at some random distance. As given angle is phi, I cannot directly draw this A1 C1 30 degree incline. I have to draw this true length. So I will take distance of this AC in a compass. I'll locate that point C and will draw locus through that point. Next, ideally I am supposed to redraw this view over here once again. So now I'll take distance of A1 C1 in a compass, that is top view of the diagonal AAC. Choose A1 as a center and have intersection with this locus, and this one is going to be the A1 C1 diagonal. And now referring to this diagonal, complete the remaining view. Let's say this is your point B1 and this is your point D1. Now project all the points for the front view. Project all the points from the surface inclination step and connect the respective points. So this is going to be A1 dash, this is going to be B1 dash, this is C1 dash, and this is D1 dash. So connect those points in a proper sequence and complete the view. So this is the final front view and this is a final top view. And once you are done with solution, provide dimensions. The basic side of the square is given, so that dimension we need to provide. This inclination 45 degree and this inclination 30 degree. Here I will provide some additional insights so that you can solve such kind of examples easily. So in the last session we discussed two scenarios, how the solution is going to proceed. If this is step number 1, step number 2, step number 3, step number 4, step number 5, step number 6, or sometime your solution may start from the front view. So step number 2, step number 3, step number 4, step number 5 and step number 6. So always this solution is going to proceed in a zigzag way. So here onwards you need to check one additional thing. Whenever you reach the step number 4, from 4 to 5, you are going to rotate the view without changing its dimensions, right? You are simply going to provide the rotation. So the view that you have drawn in step number 4, exactly same view you are going to draw at step number 5 also, but at different orientation. Now while rotating that view, you are going to refer to something. It might be a side, it might be edge, it might be axis, it might be diagonal, diameter, etc. It could be anything. because the last step is, we know that it is other inclination. The second step is surface inclination, and the step 1 is basic view. So in other inclination, whichever reference you are going to consider, check whether that reference is in true length. What you need to check, whether you are following this scenario A or scenario B. In both cases, just check whether the reference that you are considering to rotate the view 5, that reference has to be in true length. If it is in true length, and if it is showing a reduced length. If it is in true length, then you need not to worry about anything. You just proceed with the solution. Means you need not to do any additional things. Simply rotate that view, the view that you have got in step number 4, rotate it referring to inclination with HP or VP, and complete the solution. If that view is showing reduced length, means it has got reduced its length compared to basic view, then you need to read the question statement once again. If that question statement has wording like front view or top view of that reference, the reference that you are considering, it has got reduced its length in step number 4, and if question has a wording of front view of that reference or top view of that reference, again you need not to worry about any additional step. Just proceed with the solution, rotate that view and proceed with the solution. But if in step number 4 you are going to rotate that view, the reference has got reduced its length, and question has no wording of front view or top view of that reference. So in that case, you need to refer to true length, or you need to refer to basic view. Draw that basic view on the given inclination, or draw locus through that point, and then complete the solution that we have done over here. Okay. So if I correlate this thing, see, this is step number 4. When you reach step number 4, now you are going to rotate this view and draw the step number 5. The reference that you are going to consider is diagonal passing through corner with the corner which is in HP. So this is the diagonal AC. Okay. Now because of inclination of that plane with HP, this diagonal has got reduced its length compared to basic view. So this is top view. Okay. And question says that a diagonal passing through that corner is inclined at 30 degree to VP. So the diagonal has got reduced its length, and question doesn't say top view of that diagonal, and because of that one I need to refer to basic view, draw this original length or true length inclined at 30 degree, mark the locus, and then draw this reduced diagonal on that locus and complete the view. This concept is basically, you can relate with the projection of line. Let's say this is A, this point is B, this is top view, and this is B2. We know the inclination of true length is denoted by phi, and inclination of top view is denoted by beta. So we locate the true length first, draw a locus through that point, and then we locate the top view. same rule that we are going to apply to this projection of plane. Draw the projections of lamina of diameter 50 mm resting on HP, resting on HP on a point on the circumference. So there is a circular plate. Let's say there is one point A and on this point it is resting in HP and it is also inclined to HP. Next, there are additional two conditions given in other inclination. This is also part of other inclination and this is also part of other inclination. So in other inclination, the first scenario is top view of diameter making 30 degree with VP. So this is inclination beta. Inclination of top view of diameter is given, and second one diameter AB 30 degree inclined to VP. So this one is phi. So in that case you need to locate the true length first, then on locus we need to draw its top view. So those two things we need to consider. So first one, as it is resting in HP on one of the point of the circumference, so in a top view you are going to get the circle. So in top view you will get the circle. Once you draw the circle, split that circle into certain equal divisions. So either split it into 8 equal divisions or split it into 12 equal divisions. So let's say this is 1, let me change the color, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Once you draw its top view, project all the points vertically for the front view. As it is resting on one of its point of circumference on HP, and to draw basic view we'll have to make it completely rest on HP. So the front view is going to be on XY line. So this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6, 7 and 8 dash. Now the second step, the plane is inclined 40 degree to HP. So first locate this point 1 dash and then draw a line incline at 45 degree. This is going to be, sorry, this is going to be equivalent to this front view. We are just going to rotate the view of same dimensions as that of basic view. Mark the intermediate points as well. So this is 2 dash, 3 dash, 4 dash, 5 dash, 6, 7 and 8 dash, and then project all the points for the top view. Then project points from the first front view as well. Now mark the intersection points. So this is 1 1, 2 1, 3 1, 4 1, 5 1, 6 1, 7 1 and 8 1, and then connect all those points with a freehand curve and complete the ellipse. This has become little weird, so I'll try it once again. So let's say this is half of the ellipse and this is half of the ellipse. Okay, so this is up to step number 4. This was the step number 1, step number 2, step number 3, 4. Now step number 5, we need to draw twice. First we will draw the solution for A, this A, and then we'll draw the solution for B, the condition B. The first one, top view of diameter AB is 30 degree inclined to VP. So from here let's draw a line which is inclined at 30 degree, and on that on that inclined line we are going to place this diameter 1,5, because this diameter is supposed to be inclined 30 degree. Top view of this diameter, this is top view, whereas this is true length. If you want to make this true length incline, the required angle is phi, and for top view required angle is beta, because we are drawing it in a top view. So phi and beta. In a reverse scenario, if those two are supposed to be in a part of front view, then required angles are going to be theta and theta and alpha. So on this 30 degree line we are simply going to locate 1 1 and 5 1, because the first one is top view of diameter 30 degree inclined to VP, so given angle is beta, so we can draw this top view directly on this 30 degree line. So this is 1 5, then locate the remaining points. You know how to locate the remaining points, and then complete the ellipse. Okay, then project all the points for the front view. So let's say this is point, project all the points. Okay, I'll first name those points. So this is 2 1, 3 1, 4 1, 6 1, 7 1 and 8 1. So I'll project those points from front view as well. Okay, I'll extend this line, because for solution of B I'll have to project those points once again. So to avoid that one, I'll project it right away. Okay, so this is 1. Where is the 1? So this is going to be 1 1 dash, this is 2 1 dash, this is 3 1 dash, this is 4 1 dash, this is 5 1 dash, this is 6 1 dash, this is 7 1 dash, and this is 8 1 dash. So connect those points in a proper sequence and complete the view. Okay, so this is solution for the A. Now while drawing solution for the B, once again let's draw one line inclined at 30 degree, locate the point 1 1. Now here the given angle was beta, but here given angle is phi. So on this 30 degree line we need to mark this true length. So let's take distance of true length from the basic view and locate the point 5, locus through that point, and then take dimension of the top view, because ultimately we are supposed to draw this top view only, but that different orientation. So take 1151, have intersection, so this is going to be that diameter, and referring to this diameter, locate the other points and complete the view. Okay, as I am drawing it as a freehand sketch, so it might look little weird, but when you follow or when you use all the instruments, you will get it its exact shape. So this is 2 1, let me change the color, 2 1 3 1 4 1, this is 5 1, this was a 5 because it is a true length, and this is top view. So 5 1 6 1 7 1 and 8 1. Now project all the points. This is 1, this is 2, just a second, this is 3, let's say this is 4, this is 5, this is 6, this is 7, and this is 8. Now mark the respective points. Oh sorry, this was supposed to be on xy, I draw it above xy, but that is part of xy. Okay, so this is 1 1 dash, 2 1 dash, 3 1 dash, 4 1 dash, 5 1 dash, 6 1 dash, 7 1 dash, 8 1 dash, and connect those points and complete the view. So this is going to be the final solution. I hope you understood it well.